I think it helps to sketch a diagram for these kind of questions. This is question 9. So that's our particle mass 0.8 kilograms. Its weight is 0.8 g going down. It's got a force roughly in this direction of 4i plus 3j, 4i plus 3j. And we're told that it's accelerating vertically upwards, so it's going to be accelerating in that direction, which means that there must be a force over on this side that cancels out this 4 here, otherwise it wouldn't be going vertically upwards. So that means this force over here must be minus 4i, and we're told it's plus 5j. So that answers part A. The answer to part A is just k must equal minus 4 in order for the horizontal forces to cancel each other out. You can tell it's going to be a quick answer because there's only 1 mark and it just says write down. No calculations necessary. So k is minus 4 and the diagram looks like that. So for part B, we need to find a velocity. So at some point we're going to need to use the Suvat rules. The only equation connecting the Suvat rules with forces is F equals ma. So if we do, remember it's always the resultant force equals mass times acceleration. So if we can find the acceleration, we'll then be able to use the Suvat rules to find the velocity of the particle. If we resolve vertically, all the forces going up, well, the upwards forces will be this and this. So we've got 5 plus 3 going up, and going down we've got minus 0.8 g newtons going down, and that's going to equal the mass 0.8 times by the acceleration. Typing this into the calculator will give an acceleration of 0.2 meters per second to minus 2. So that is the acceleration vertically upwards. We've calculated that now, and so we can now think about using the Suvat rule to answer the question to find this velocity. So if you write down what we know, I think probably should write all this in vector form. So u is going to be 4, 7. Let me just write that a bit clearer. So the initial velocity is going to be 4, 7, because it tells us that in the question. The final velocity is what we're trying to find. The acceleration we know is 0.2 meters per second going up, so it's 0, 0.2 in vector notation, and the time isn't a vector, it's scalar. That's 10 seconds. So the Suvat rule connecting t, a, v and u, we can use v equals u plus at. Sticking all our values, we've got 4, 7 plus 0, 0.2 all times by 10, and you can see that will give a velocity of 4, and 7 plus 2, that will give a velocity of 4.9 meters per second. The question uses I and J notation. I prefer using column notation for working out here, as you can see, but it's probably a good idea to write it back in I and J notation, since that's what it says in the question. And this will be in meters per second.